Okay, guys, we're rolling now. Okay, so everybody should have a piece of graph paper and a ruler, and we are going to do a little practice here together of graphing lines, because what we're going to be doing today is investigating how the equations of parallel and perpendicular lines are related to each other. Okay, so I have a few lines we're going to look at, give you their equations up here. And then we're going to graph these things together. So we're going to do y equals 2/3 x plus 5. We're going to do y equals 2/3 x minus 1. And we're going to graph y equals -3/2 x plus 2. Okay, now when I graph them, and we're going to do all these on the same coordinate plane. Okay, all together on the same coordinate plane. Now when I graph them, I'm going to use some different colors to help kind of emphasize some stuff, but you don't need to do that necessarily. Yeah? You may, just be quick. All right, so let's take this coordinate plane. Guys, quiet, please. I don't care. You're both being stupid. Stop it. All right, I'm going to try and make this thing 10 by 10. Yeah. Might need to expand it out a little bit. And I might run out of room going up here. I think I'm just going to make it up to 8 this direction then. But this should still be plenty of room for what we need to do. Alright, so like I said, little review of graphing some lines. So the first one, go ahead and make this will be our red line that I'll do. So we talked about, at the end of the last assignment, you guys had to identify slope and y-intercept of that, of equations of lines. So for this one, what's the y-intercept? Yeah, Savannah. 5. Okay. So that means on the y-axis, we start at 5. So put a little point right there. Bless you. Okay, so then, what's the slope of this line? Somebody else? Nolan? 2/3. Okay, so what that means is from that point, I can go up 2/3, and there's another point on the line, right? Okay, it's a rise over run thing with slope. Okay, so up 2, 1, 2/3, 1, 2, 3. There's another point that's on that line. And then using your ruler, you can make a nice, straight line across there. So something kind of like that. That's the first one. All right, I'll do blue for the second one. So now we're going to do 2/3 x minus 1. Okay, so y-intercept this time is -1, so we're going to start down here. And then same thing with the slope, right? From that point, up 2/3. So we can just count that. Up 1, 2/3, 1, 2, 3. So that also has a slope of 2/3. And then we can put that together. So those two lines appear to be what? Right. Parallel, okay? So take a look at What do you notice about their equations where I could just look at those and say, aha, I know those two are parallel? Yeah. Slope is the same. Okay. So before we graph this third one, let's just go down underneath this and write that down, because that's important. So parallel lines have the same slope. And think about how you use slope. Doesn't that make sense? It's rise over run, right? So it's telling you how far up and over you need to go to make it. So it's kind of like measuring the tilt of the line. Well, these two have the same slope, so they have the same tilt. Lines that have the same tilt, those are parallel. Okay, so it's that same slope that sets up that those lines are parallel there. Okay, all right, let's come back and do the next one here. I think I'll make this one purple. All right, so this one, different slope this time. Negative 3 over 2x plus 2. So we're going to start at 2. And this time, down 3 to the right 2. Okay, so go ahead and do that. Go down 3 from there. 1, 2, 3, and then over 2. 1, 2. All right, so let's connect those together. So we get a line that looks something like that. So what do you suppose is true about that purple line that we just made? Yeah, Nolan? It's perpendicular to the other two. Correct. So we have just now made a couple of parallel lines and a perpendicular line with the other two. Now let's go back to the original equations. We said for parallel, the slopes are the same. There's a relationship with slope again with perpendicular, but it's not that they're the same. It was a different slope this time. But what did I do to the slope to make it so that I knew it was going to come out perpendicular? Savannah? Did what? Opposite in what way? Okay, so there's actually two things going on there, right? The fraction flipped, and which is a reciprocal, right? I took the reciprocal and I made it negative. So I changed the sign, did the reciprocal. So we call that the opposite reciprocal slope, or negative reciprocal slope, however you want to say that. So perpendicular lines opposite reciprocal slopes. Okay, so flip the fraction, make it negative. If the original slope was negative, the perpendicular slope should be what? Positive, right? So if it started positive, the new one should be negative. If it started negative, the new one should be positive. The sign just changes, okay? So I always just remembered it as flip the fraction, change the sign. Got it, okay? So that's what we're looking for with parallel and perpendicular lines. So first of all, if I give you some equations of some lines, can you tell me which ones are parallel and which ones are perpendicular? Okay? Just by looking at their slopes. And then the next thing that I'd like you to be able to do is if I give you points that a line will go through, can you tell me which ones are parallel, which ones are perpendicular, that sort of thing. So those, you have to actually like calculate the slope first and then work the rest of the way through it. Okay, so let's try that idea here real quick. So let's see if we can identify which are parallel and which are perpendicular. So I'm going to give you some equations to start with. Let's make that a 12. Okay, so we'll say this is A, this is B, this is C, this is D, this is E. All right, so I got 5 equations there. I'll zoom that in just a little bit so we can see those better. So got line A, line B, line C, line D, and line E. And which ones are parallel, which ones are perpendicular? So let's try and get some people who haven't spoken yet today. One moment.
Excuse the interruption. We have a few announcements. Girl Scout Troop 30199 is doing a project collecting broken pieces of jewelry or single earrings that will make them into new jewelry and sell it for profits, benefiting orphans in South Africa. The collection bin is in the cafeteria during lunches. Please bring in any odds and ends you might have. Students, would you like to wear a hat to school? Tomorrow, students can wear a hat by paying $1 to donate. A $1 donation in support of Helen DeVos.
Start with the easier one here. Oh, yeah, question? Hold on a second, because I'm going to ask specifically. So first question, which of these lines are definitely parallel? Anybody help me with those? And we get somebody who has not spoken yet. Yeah. Right. A and E, right. Okay, so, and we're going to practice here using the correct little notation. So A is parallel to E. Say it like that. Okay. Now, perpendicular. Again, people who haven't spoken, I think all 3 of you have today already. So you haven't yet. Yeah, go ahead.
I have what?
Oh, well then forget you. Somebody else. Yeah.
B and D.
B and no, those are not perpendicular. Now B and D, here's the thing. Look at those 2 slopes, because we're focusing on slope, right? Look at the slopes of B and D. They're opposite signs, but they are not what that they need to be? Reciprocal. So let's find some reciprocals in the mix. Yeah. B and C. Yes, those are. Okay, B and C, 1/3, -3, because 3 is 3 over 1. Right. So 1/3 is the reciprocal of 3. They have opposite signs. Yup, that works. So B is perpendicular to C. Those work. All right, any others we see in there, Jace? Say it again. I didn't hear the first one. D and E, yep, good. Yep, because we've got -1/3 and +3. And I believe there's one more set in there. Somebody who has not spoken yet. Yes. You haven't yet. Yeah, go ahead, Seth. D is perpendicular to A. Right. Okay. Feeling pretty confident with that? Okay. All right. Now, if we take a look at these where they're not all written out for you, but rather I give you 2 points that are on a line, and we have a whole bunch of those, can you go through and tell me which are parallel, which are perpendicular, and all that? All right. And I'm going to actually have you guys work through a question that's right on your homework assignment. Hint, hint. So you could just, look at this in your notes and copy it down. I know, I'm so nice. So number 7... Let's zoom this guy in. Now, got to be careful with this one, okay? Because there are some lines in this picture that look like they're parallel to each other, but aren't actually parallel. And there are some that look like they might be perpendicular, but aren't actually perpendicular. So what's the only way to really know for sure? Either not just write the equation, even simpler than that. What do we need to know about the equations? Yeah. Find the slopes, right? I don't need to worry about the full equation. I just need to figure out what's the slope of each one of those. Okay? So let's talk through that a little bit here. Actually, if you guys could, so I don't have to keep this up here, could you open your books to page 160 so you can see this picture in front of you? All right. Shh. So what I'm going to do is I'm going to unfreeze this. We'll go back to here. And I'm going to write down, for each line that's in that picture, we're going to copy down the coordinates of the 2 points that you have. So for line A in that picture, that would be the blue line. We got -1, 4, and 5, 6. For line B, we have the 2 points, -1, 1, and 3, 2. Dope. What? I said dope. Yeah, I did say that. For line C, -3, -2, and 3, 0. And then line D, this is the one that looks perpendicular, but let's double check. 1, 6, and 3, -2. Okay, so slope for each of these, what do we get? How do you find the slope between 2 points? It's a good question. Kind of need to know that. Who can help us out? How do you find the slope between 2 points? Yes, sir?
You add the two parentheses thingies.
Nope, we don't add them. Yeah. You subtract, and then do what with the answers? You divide. It's the change in the y divided by the change in the x. Okay? I'll just put this down here. So, have you guys all seen that little triangle symbol before? It means change. Oh, well, here you go. Here's your first exposure to it. That little triangle means change in. Okay? So it's the change in the y divided by the change in the x. So just look at each one of these individually then. Okay, 4 is this y value. 6 is that y value. What is the change in the y? 2. Okay, so this slope is 2 on top. -1 is the x. Up to 5, what's the change in the x? Yes, 6. So I got 2/6, which is 1/3. Reduce that to 1/3. Okay, next one. What's the change in the y? 1. What's the change in the x? 4. So I got 1/4 is the slope for that one. Okay, let me step you through it one more time. Change in the y. Y goes from 1 to 2. So it changed how much? 1. That's where this 1 comes from. -1 is the first x. Up to 3 is the second x. How much did the x change? 4. So it's 1/4. Okay? So that's what we're doing. -2 to 0. 2. -3 to 3. 6. So 2/6. 1/3. Ooh, we got some parallel lines there. Okay, this one. 1 to 3. 2. Oh, my bad. I did that backwards. It's supposed to start with the y's. So the y, 6 to -2. How much did that change? Went down 8 though, right? So -8. So -8 on top. And then the change in the x, 1 to 3. That's 2. So this is going to be -4. Okay. So we have our four slopes are 1/3, 1/4, 1/3, and -4. Do you see any parallel lines in there? Mr. Ball? A and C. Okay. So A is parallel to C. And then do we see any perpendicular lines in there? Somebody who has not spoken yet. You have. Yes, you have. Don't lie to me. Anybody else? Where are my perpendicular lines? We have some in there. Tiara? B and D. Good. 1/4 and -4. So B is perpendicular to D. Okay? So there are all the parallel and perpendicular lines that were in that picture. Okay? There were a lot more that looked like they were parallel and perpendicular, but these are the only ones that actually were. Okay? All right. One quick thing I want to make sure that I talk about with you guys too here is equations of horizontal and vertical lines, because you're going to deal with those some here too. What way is horizontal? Yeah? This way, right? Left to right? So a horizontal line has a constant what value? X or Y?
Y.
The Y value stays the same, right? Okay, it's going the same way as the x-axis. I know that's confusing, but think about it. You just pick a Y value and then let it stay there, right? The Y is staying the same, okay? So horizontal lines are always Y equals whatever number you picked, okay? So it's always some kind of Y equals. And then likewise, vertical lines, vertical, yeah, I spelled that right. Vertical lines go up and down, right? And with those, what stays the same? The X, right? So it's X equals whatever that number is straight up and down. So that's always going to look like an X equals a number. Okay? So I'm going to plot a couple of lines, and I want to see if you guys can just use this idea real quick. Give me an equation for each one. All right, so let's say we've got this blue line over here. Oh, and assuming these are all, I guess, 1 unit. So there's 1, 2, 3, -1, -2, -3. Okay, so there's that blue line, and then do this red line here. So what is the equation of the blue line? We'll call it L. Somebody has not spoken yet. What is the equation of the blue line? You already answered a bunch. So have you. So have you.
I've only answered 2.
I've only answered 1.
I know. You still have. Let's have Mark do it. Well, where is it crossing the x-axis? 3. So what should that equation be? Is it y equals 3 or x equals 3? X equals 3. So for line L, the equation would be x equals 3. That's it. That's the equation of that whole line. Okay. Using that same kind of logic, here's line M, the red one. Again, somebody who has not answered anything for me yet today. What's the equation of line M? There we go, Mr. McKinnon. Y equals 1. Yeah. Okay. And what do you notice about horizontal and vertical lines? They are intersecting, but more than that, perpendicular, right? They always form a right angle. So every single horizontal line is parallel to another horizontal line, and every vertical line is parallel to another vertical line, and they are perpendicular to each other all the time. So that's why I said you're going to have to deal with these in this section because we're talking about perpendicular lines, and hey, look, these are perpendicular. Okay, so that's how you can work with those. If you see equations that are written like this, okay, with no, y equals something times x plus something. If it's not in that kind of form, you're just looking at horizontal or vertical lines then. So just make sure you understand this little idea and you'll be fine. Okay, with that. Very last thing we need to be able to do when we're done is, can you create a whole new equation of a line that is parallel or perpendicular to another one? I think you can. So we're going to look at making some new equations here. So let's say I want to write the equation of the line parallel to y equals 5x plus 3 through the point 1, negative 2. Okay? So it's not enough to just say I need it parallel. I have to also give you a point that it goes through, because there's an infinite number of lines that could be parallel to one. So, okay, which specific one? Okay, we'll make it parallel and make sure that it hits this point too, and then we can do it. So first, based on what we've been talking about so far, what should be the slope of my new line? Somebody who's not answered yet. Standing taller will not make me call on you. What's the slope of my line need to be if it's going to be parallel to the one that I wrote right there? Yeah, 5. Thank you. All right, so my new slope, I know m has to be 5. Okay, so I have a slope that I need, 5, and I have a point that it has to go through, 1, negative 2. So I need to somehow make an equation for that. Well, when you guys do slope-intercept form, you've probably seen this before. Y equals mx plus b, right? Should look familiar at this point. Well, you've looked at it before. Anyway, I already know the 5, so I can put the 5 in for m. So right now, this now becomes y equals 5x plus b. And what's the only thing that I need to know about that equation before I have a linear equation all done? Yeah, right. B, okay? So I don't have a b to just plug in right now, but what I do have is a point. And a point is x, y, right? So if I take x and y, put them in, I can solve for what I'm missing, right? Solve it for b. Okay? Got to do a little algebra there, but I think you can handle it. So let's plug in. So the 1, remember, like I said, this is x, this is y. So 1 goes in for x, negative 2 goes in for y. So I've got negative 2 equals 5 times 1 plus b. All right, so if I multiply 5 times 1, that's 5. Subtract it to the other side. What's b have to be here then? Negative 7. Yeah, negative 2 minus 5 is negative 7. All right, so now I do have the b that I need. So now I've got y equals 5x, that's with the m in there, and then with the b, minus 7. Boom, done, got it. There's that equation. Okay? Like I said, you algebra people would probably be a little happier today. All right, this is the kind of the algebra stuff we're doing here. Now, I'm going to change something here real quick. We're going to do another example. The only thing that I'm going to change is I want an equation not of a line parallel, but perpendicular. Repeat with perpendicular instead, and let's see what changes. I won't. think. No. All right. So repeat perpendicular this time. Okay. So it still has to go through the same point. Still looking at the same equation of that first line. But now I want it to be perpendicular. So what's the only thing that's going to change in my setup? Yes. Slope. And what will my slope be this time? Somebody has not answered yet. You all have. You have. Tiara has. That's true. Oh, yeah, go for it. It's going to be that negative reciprocal. So for this one, what should it be? If the original slope was 5. What's the new slope have to be then if it was 5 before? There you go. Negative 1/5. Okay? So the rest of the process is exactly the same though, right? I got a slope. I got a point. Still 1, negative 2. I'm using that same point this time. Okay, so remember this point is my x and my y. So if I start with y equals negative 1/5 x plus b, I can still plug these in and then get my slope. So y is negative 2, x is 1, and now I got to solve that for b. Oh, now we got a little fraction work here, but I think we can handle that. So negative 2, and then we have to add 1/5 to negative 2. So let's do a little common denominator work here. We got to put them both over 5. So if it's negative 2, it would be what over 5? Negative 10. Because 10 over 5 is 2. Okay, now it's going to probably look a little easier. If you add or subtract fractions, remember the denominator stays the same, the numerator you add or subtract. So I need to add 1/5 to the other side. So what is negative 10 plus 1? Yes. Okay, so it's negative 9 over 5. So now I can dump that into the equation too. So I've got y equals negative 1/5 x minus 9/5. Got it. There's my perpendicular line. Okay. And that's it. That's all the stuff that I am going to expect of you out of this stuff. Okay? Identifying parallel and perpendicular and then making equations with it too. Okay? All right. Let's get to work.